So today's lesson is about density. Density is the measure of how closely packed an object's particles are. LES. So yesterday you talked about states of matter and particles. So density, if you draw, that is not great. If we've got a box, something with low density, the particles are going to be spread out. If we draw another box, something with higher density, the particles are going to be much closer. The box will be more packed. Okay? There is a formula for density. You can find density by doing mass divided by volume. So when you're talking about density, we're going to say that something could have a low density or high density. Think about this as a spectrum. So it could be low, it could be high, it could be anywhere in between. So they have a little bit better pictures here. Low density, their particles are going to be spread out. The particles of the object will have room to move around. If the higher density you have, the particles are close together. So if the particles are more spread out, what does that mean about in between them? If there's very few people in this room, what does that mean? Yeah, there's a lot of space. There's empty space between us. If we had a lot more people in the room, there's very little empty space. I feel like they could have written that a different way so it wasn't the exact same, but empty space for both of those. So some things that have really low density, 0.002 kilograms per liter. This is helium. That's a really low density. Still pretty small, 0.7 is the density of gasoline. And then a little bit higher, seems like it should be way different, but it's not. 0.8 is the density of wood. So that feels weird. But the particles of gasoline and the particles of wood are really not that far apart.
I mean, it kind of makes sense. It allows water to get into it.
Okay, in the middle, just 1 kilogram per liter is the density of water. So we kind of compare most things to water when we think about density. And then some things that are more dense. 1.42 is the density of honey. .6 is the density of glass. And then 11.3, that's really high, is the density of lead. Okay, go ahead and look at the back of this page. So this first blank, water has a density of 1 kilogram per liter. Any substance with a density less than 1, what do you think is going to happen to it if it's in water? It will float. If you're less dense, you float. If you have a density that's greater than 1, you're going to sink. Fall to the bottom. So this doesn't just have to be water. Any less dense object or substance will float on top of any more dense object. So this picture underneath here with the different colors, different substances that are more or less dense than each other. Whoopsie. It's like down here on the very bottom, we've got honey. So of the things in this beaker, it's the most dense. Kind of in the middle, they've got like dish soap. So that dish soap is less dense than honey, corn syrup, maple syrup, and milk. But it's more dense than rubbing alcohol, vegetable oil, or water. They also have objects. It's kind of hard to see over here, but there's a popcorn kernel right here. And then I think it's almost impossible to see, but there's supposed to be like a die, like Yahtzee dice. They are right above where the milk and syrup meet. So the popcorn kernel is more dense because it's a lower. The ping pong ball is the least dense. It's floating on the very top. Okay? Any questions about those pictures? Okay, so let's do some practice finding densities. So remember, the formula for density is mass divided by volume. So for number 1, a bowling ball has a volume of 5.3 liters and a density of 1.4 kilograms per liter. They're asking us to find the mass. So before we plug numbers in, density equals mass over volume. What do we need to do to get mass by itself? Okay. I'm going to do it with the letters first, but yes. So we want to undo the division by multiplying the volume. So mass will be volume times density. And they gave us those numbers, so we're just going to plug that in. Our volume was 5.3 times density was 1.4. Oh, I'm going to rewrite that so you can see what that was liters times 1.4 kilograms per liter. So your numbers are just going to multiply like normal. What is 5.3 times 1.4? 7.42. And then what's going to happen if we have liters and then kilogram over liter? Yeah, we have a liter on top and on bottom, so they're going to go away. Mass is measured in kilograms. So make sure you have a unit on these answers. All right? All right, for the we do, a golf ball's mass is given 0.046. Its volume is 0.04. Will the ball float in water? What do we need to do? We know the density of water. We need to find the density of this golf ball. How are we going to do that? Divide. Good. Mass goes on top. So what is 0.046 divided by our volume? 0.04? 1.15. This would be kilograms per liter. So our density is 1.15. The density of water is what? 1. So 1.15 is greater than 1. What does that mean about this golf ball? It will sink. The ball will sink. So that was really a two-part question. You needed to find the density and then decide if it will float or sink.
Wait, so what will happen in the first one? Oh, never mind. Never mind. It's not asking the same question.
Okay? And then the last one you do, find the density of a brick that has a volume of 1.03 liters and a mass of 1.63 kilograms. So they gave us volume and they gave us mass. Oh my gosh. What's the setup going to look like? Good. Mass on top over volume on bottom. So go ahead and plug that in. Gosh. Gotta fit in there at least once.
1.5.
8. Okay. And then your unit.
Kilograms per liter? Or
Kilogram per liter. Yeah.
Oh, it is liter. Okay, cool.
You're good. All right. Are you okay with those? Okay, we're going to skip the density and buoyancy page because we don't have as much time as I would like. But we are going to talk about this simulation. If you want to pull this up on your phone, you have to search PHET, P-H-E-T, density simulation because the tiny URL is broken. So I'm going to pull this up. I'll make this fit. Okay. So we've got this simulation.
Carry them all the way to the side and make it to where it'll just go natural.
It'll make it.
Just all the way to the side. And it should just prop
Thank you.
on each side. And then just do that with the other one on you.
Okay. Except it's going to drag it to my, oh, I almost got it. Nope. Made it huge. That's fine. Okay.
And it works right there.
Yeah, that's good. All right. Can I make this a tiny bit smaller? All right, so number 1 says use the drop-down menu to select each type of material for your block and put each block in the water. So number 1, first thing we've got here is wood. And it asks you which materials float and which sink. So here's a picture of a wood block. You can decide where that one goes. Is it floating or is it sinking? It's floating. Okay. All right, so styrofoam.
I put ST for styrofoam.
That's fine. Ice is next. Try to trick you.
What is that again?
This is ice. It went down lower, but it is still above water. Next is PVC. PVC, plastic. PVC.
Yes.
Yeah. It is sunk. Okay, next we've got brick. That one didn't even move. And then we've got aluminum last. Tricky, tricky. Okay, so it asks you to decide which ones float, which ones sink, and then why do some float and others sink? We just talked about this. Answer that question on your own, please.
For aluminum.
That's fine. Why do some float and why do some sink?
Hey, Gar, if you're still in the building, can you come to the front desk, please? Nathan, Gar. You'll be there in just a moment. Thanks, Chris.
If you're watching the video, pause and finish answering those questions. Okay, the next one says, we're going to go back to wood. Lift the block completely out of the water. So if I pick this up, what is the water's volume? So it's telling you over here. 100 liters. Oh, why can't I see it? Okay. Now push the block completely under the water. What is the new volume? I forgot. I can't write on this. And click. So here's the water above, or the block above. When I hold the wood block underneath the water, what is the new volume? $105. Okay. Number 5, subtract your answers from 1 and 2 and find the volume of just the block. Why did it do that? Okay, so we had 100 liters, 105 liters. So what is the block's volume? Yeah. Okay? The next part, this is called water displacement, what we just did. So you can find something's volume by using the displacement, kind of like the distance displacement we talked about in physics. So the next one, we need more blocks. So we want the same density for these blocks. Name 2 things besides their color. That's irrelevant. What is 2 things that are different about these blocks? Okay? They have different sizes. We don't have those things, but what is listed there? What does their kilogram stand for?
Density.
Their mass. So they have different sizes and different masses. Part B says read the mass of the yellow block and find its volume by using water displacement. So what is the mass of the yellow? 3 kilograms, okay. The water's at 100 with the block out. With the block sunk all the way down. It's at 106. So what is the block's volume? Yeah. 6 liters. What's your question, Coda?
So the mass is 3 kilograms.
The mass is 3 kilograms.
6 liters.
The volume is 6 liters.
Okay.
So knowing those two things, you can find the density. What is the setup going to look like to find the density of the yellow block? Almost. 1 over 2 or 0.5. One half kilograms per liter. You can use a decimal. 0.5 is fine. Okay. We're going to do this again, but with a different color block to determine if it really does have the same density. So, somebody, blue, green, or red?
Blue.
Blue. Everybody okay if I clear the screen?
Yeah.
So if we do this again with blue, what is blue's mass? 2. If I hold it under the water, what's our volume going to be? The volume is 4. We went from 100 to 4. Okay, so for the blue block, mass was 2 kilograms. The volume was 4 liters. Also 1/2 or 0.5. Do they really have the same density? Yeah, even though they're different sizes, their density was the same. Okay, any questions so far? Okay, for the next one, we're going to do these mystery boxes. Okay, box A. Find the mass by placing the box on the scale. 19.3. I'm going to write this down on paper and then I'll put it on the screen after we've done all the measuring. Find the volume by holding the block underwater. So we're starting still at 100 liters. What is our volume? 5.5. Find the density by doing the equation. Actually, we'll do that in a second. We're going to do mass and volume for all of them. For B, 0.4. And our, Yes.
Mass is 0.4.
I'll put it all on the screen in a second, but what is our displacement volume going to be?
1.0.
1. Okay. Beep. This makes me think of Stardew Valley. Whoa.
B is 19.3.
19.32. Our displacement this time for the volume is just 1. Oops, missed it. It's like a video game. Okay. D. Okay, so sorry people on the video, it didn't get saved. But we did all of these. So box A's mass, I'm going to write these on the screen if you already have them. 19.3 and 5.5. 0.41. Okay. C
19.2.
and 1. D was 5 and 5. E.
2.8 and 7.
Okay. So for all of these, to find density, mass divided by volume. So for A, what is 19.3 divided by 5.5? 3.5. Okay. Kilograms per liter. B, 0.4 divided by 1 is just 0.4. For C, we have 19.32 divided by 1. Stays itself. D, 5 divided by 5. It's going to be 1. And then E, 2.8 divided by 7. It's a point what? 0.4? All right. So, will they sink or float? 3.5 for A. Sink.
So if it's above 1,
Yep. Greater than 1 sinks.
Say 1 floats.
Less than 1 floats. So B will float. C will definitely sink. That's huge.
so the density is greater.
Yeah.
What if it's 1?
If it's 1, question mark.
I feel like it does because
It floats because it's the same density.
It's not greater.
yeah.
Just kind of floats. 0.4 floats. Okay. If you're watching the video, pause so you can write all that down. If we went back to these, how did they decide? Okay, so here's, I'll make this bigger. Here's what these could be. So for the material line,
C, I can already tell you, is gold.
C,
C is gold. It's 19.32.
okay?
And it's this.
Which one was D? We weren't sure.
D is 1.
It's kind of like just stays wherever you
D
put
is
it.
1, so it's water.
D is 1, water is 1. Density of 1. This one will kind of just stay wherever I put it.
Yeah, it's water. E is
E,
wood,
so E is wood.
and B is wood.
E is also.
Yeah, it's 1.
We got the same thing for those.
Oh, okay.
And then that means we still have A. Get off it.
A is 3.5. 3.5 is diamond.
A diamond. Okay, so then the last couple questions there ask you why. Come on. Why do different materials have different densities?
They have different mass.
Okay.
Yeah, different mass and volume.
Also, we talked about at the very beginning of class, or the very beginning of this packet, what is dense, like What is the definition of density? Density depends on how packed the particles are. So how does that relate to what we talked about yesterday with states of matter?
I think the more solid it is, the more dense.
Okay, solids have particles that are more closely packed together, so they're going to be more dense compared to gases.
Very dense.
Yeah, not have a very low density. If you think about, we talked about helium in the packet. Its particles are super spread out, so it has a very low density. So there might be some special things like ice and water are kind of weird, but for the most part, solids have higher density because their particles are more closely packed together. Liquids are somewhere in the middle, and then gases are low density because their particles are spread out. Okay, so that's that simulation. Do you have any questions about that part? The last page, density practice. 6.3 is the assignment for today. So if you want to, we have about 15 minutes left to work on that.